Hello students, today we will study about another problem or another example in DC power supplies. Second problem, in a bridge rectifier, if secondary voltage is 60 volt AC and load resistance is 400 ohm, then we have to calculate DC load current. Second, DC current through each diode, and third, PIV of diode, or PIV means peak inverse voltage across diode. Okay, so the bridge rectifier circuit is given and its secondary voltage is 60 volt AC. Okay, so first we have to convert the secondary voltage which is 60 volt, and it is called as RMS voltage, VRMS. So VRMS is 60 volt, and we have to convert first into peak voltage, thus RMS voltage into peak voltage. So V peak or peak voltage is equal to 1.414 into VRMS, or peak voltage Vp is equal to root 2 into VRMS, or peak voltage Vp is equal to 60 divided by 0.707, VRMS divided by 0.707. So it is called as peak secondary voltage. Secondary peak voltage Vp is equal to VRMS divided by 0.707. So 60 volt secondary voltage is given 60 volt. It is VRMS. It is VRMS, that is RMS voltage, and we have to convert it into peak voltage. Secondary peak voltage or peak secondary voltage Vp is equal to VRMS divided by 0.707. Okay, that is 60 divided by 0.707, or 60 into 1.414, or 60 into root 2. 60 into root 2, where root 2 is equal to 1.414. Root 2 is equal to 1.414. So peak voltage Vp is equal to 60 into 1.414, or 60 divided by 0.707. 60 divided by 0.707, that is 60 into 1.414, and it comes 84.86 volt. 84.86 volt. 1.414 into 60, it is approximately 84.86 volt. Okay, so this is called as a peak voltage or peak secondary voltage, Vp. Okay, now we have to calculate DC output voltage, average DC output. So average DC output voltage VDC is equal to 2 Vp upon pi. 2 Vp upon pi, that is 0.636 into Vp. 0.636 into Vp, and Vp is 84.86. So 0.636 into 84.86, and it is equal to 53.97 volt. So this is the DC output voltage of bridge rectifier, Puleo bridge rectifier. It is the DC output voltage of Puleo bridge rectifier. Now we can calculate DC load current. So we know that I is equal to V upon R. I is equal to V upon R. So here I means DC load current. So I is equal to VDC upon RL. VDC means DC output voltage, because load resistance is connected at the output of the bridge rectifier. Load resistance RL is connected at the output of the bridge rectifier. Therefore, DC load current is equal to DC output voltage VDC divided by RL. I is equal to V upon R. So DC output voltage VDC is 53.97 divided by RL, and that is load resistance is 400 ohm. So 53.97 divided by 400. Now we can convert it into milliampere. So again we can multiply this factor into 1000. 53.97 divided by 400 into 1000, and it comes 135 milliampere. So DC load current is 135 milliampere. Okay, then we can calculate diode current, that is current through each diode. It is exactly half of the DC load current, because each diode in a bridge rectifier circuit, all these four diodes or each diode conduct during the half cycle only. During positive half cycle, two diodes are conducting, and during negative half cycle, the other two diodes are conducting. Okay, so each diode conducts for the positive or negative half cycle. That is, for each half cycle diode is conducting. Therefore, we take DC current through each diode. It is half that of the DC load current. So DC load current is 135 milliampere. So DC current through each diode is 135 divided by 2. That is 67.5 milliampere. 67.5 milliampere. Then we have to calculate peak inverse voltage, PIV, across each diode. We know that in folio bridge rectifier circuit, PIV across each diode, peak inverse voltage across each diode is Vp. So PIV is equal to Vp, and Vp is equal to 84.86 volt. Vp means peak secondary voltage. So PIV is equal to Vp, and that is peak secondary voltage, and PIV is equal to Vp, and it is equal to 84.86 volt. So PIV across each diode is 84.86 volt. Okay, so we will stop here.